I wanted to take a few moments to go over how to use the linear regression template that will be posted on Blackboard. So here on the left I have a whole bunch of car data for a total of 11 cars of the weight in pounds and the miles per gallon. We want to treat the weight as the explanatory variable and the miles per gallon as the response variable. So in order for us to use this template here to the right, we first need to take our data and copy it, and then paste it into our template here. Now, as you might have noticed, it did take up all of the entries. If for whatever reason there were some entries left here on the bottom, just delete those by either just, deleting each cell or clearing the contents of it. Then these other values will disappear. Notice how it gives the predicted values based upon the line of best fit, and then the residuals for all of them. But for this, as it does read on here, if we want to make a residual scatter plot, well, if we first wanted to make a scatter plot of these first three rows, we could do so by highlighting those and then go to Insert, and then Scatter Plot would be this button here, and then choose this first one, and as you can see, it shows how most of this data is in a pretty good line. I'll keep that one down here. I made multiple copies. Let's delete that one. Okay. And then for the residual scatter plot, we would sort these two. And then go to Insert, Scatter Plot. This would be the residual scatter plot, which, as you can see, we have a whole bunch of data here on the top. Only a couple on the below and one vastly below. And let us also make, based on this, a residual. Let's look at the histogram. That is not the histogram option. Here we go. Which of course does not look as nice as it should. Let me edit this. And that's the wrong section. Let me edit this to make it be a bin of, this has 2. I've got 5. 5 provides this type of graph, which I wish I had more room for this. Provides this type of graph, which, I mean, doesn't really show any normality inside of it. Let's change this up to 10. And as you could probably tell by just looking at this graph, no matter how many options I choose for this, it's not going to look exactly normal. It looks kind of all over the place, with a slight left-hand skew for the residuals. So do bear in mind that this doesn't really cover one of those assumptions for the test. We could also draw a box plot by again selecting those two and then go into that statistical graph section and then click box and whisker. That will give us this, which it will show our data up here as the box plot for that. And as we can see, there's, a bit of variation in there from that normality as well. But based upon this, we could click on one of these sheets down here on the bottom. This residuals one gives us a much better look at the residuals for the graph. This one also shows that slight left skew, but this particular histogram of those residuals looks at least closer to a normal distribution. Again, it's a little bit off due to the skewness over here. So it does it has a minor violation in it. But since we're using a t-value anyway for these, that will always account for most of this discrepancy. And notice how it gives all those residual values as well. But the regression line for this, it gives us the slope of this regression line of negative 0.0070, and the y-intercept is 43.4132. It gives us also an r-squared value of a is 7.69, which, makes sense based upon this graph down here. It falls pretty much in a straight line except for 1 point. And if we wanted to, we can even predict values in here by typing the x value in this box. So let's say, for example, if I wanted the average weight of a, let's do 3,000 pound car, it would give us the average predicted value of 22.3582 miles per gallon. If we click on this model inference down here, this will allow us to run a hypothesis test. It gives us the standard error of the line, of the slope. It allows us to select a confidence interval, let's say 95%. And that will give us a confidence interval around the slope. So the slope had been negative 0.0070. The 95% confidence adds and subtracts 0.0020. So the smallest it could be is between negative 0.0090 and negative 0.0050. So the fact that that's negative just indicates that we have a negative slope, a negative correlation. The t-statistic, that's also negative, negative 8.005. And then based upon whatever the hypothesis test is, all those values are down here. So if we look at these p-values down here, this first one, no matter what our level of significance is, it's definitely not greater than 0. And what we could see from this bottom two, though, the slope for less than 0, that is well less than any level of significance, and the test of not equal to 0 also gives us way lower than any level of significance that we have. Okay? Just to identify that negative slope as well. And finally, this prediction inference one, we could use to predict values. So before I had used a 3,000 pound car. So for that, we are going to type our 3,000 into this box. That will give us the standard error based upon it, and we could provide a confidence level. I'm going to change this to 95%. It gives us a prediction that we found on this, not that one. This one gives us a prediction that we have, and then gives us the confidence interval of plus and minus 1.1687, which means this particular slope, this particular value I should say, based upon the average line of best fit, will be between 21.1895 and 23.5269 to give us a point close to that line of best fit. The prediction interval, we have a separate standard error here, and if we specify, I'm going to specify this as a 95% confidence interval for the prediction. This gives us this would then give us a prediction for the interval. This gave a prediction for the mean value. This one gave us a predicted value for the observation. So the prediction interval for this, we have that 22.3582 again, but we're going to add and subtract 3.2746. So this would give us a prediction interval for that point to be between 19.0835 and 25.6328. Okay, so when we're talking about predicting a value of an observation, we are going to use, whoopsie-daisy, we are going to use this bottom prediction interval for observation. This confidence interval for the mean, that's only used for the mean when we're referring to the actual line itself and how that changes with respect to the point. This bottom one is the prediction interval for the observations. So when we're talking about prediction intervals in this class, we will be referring to this part down here. Thank you.